Find the P.G.F of P of x greater than n. This means probability generating function of probability of a random variable x greater than n. Solution. We know the probability generating function variable x. It is denoted by g(x) of t and it has the formula e of t power x. From this we write summation t power x into p of x, because here a random variable x is discrete. That's why it is of the form e of x. This can be written as summation x into p of x. To find the value of p of x greater than n, let us we take fn equals to p of x greater than n and p of n equals to p of x is equals to n. Means probability of a random variable is greater than any value can be taken as fn. Means suppose if n equals to 1, f1 is equals to probability of x greater than 1, f2 is equals to probability of x greater than 2, like this. Here p of n means p of 1. If n equals to 1, p of 1 equals to p of x is equals to 1. If n equals to 2, p of 2 equals to p of x is equals to 2, and so on. Consider the value p of x is equals to n plus 1 is equals to p of x greater than n minus p of x greater than n plus 1, because probability of n plus 1 is equals to p of x greater than n means is equals to n plus 1, n plus 2, and so on, like this. What about p of x greater than n plus 1? Means x is equals to n plus 2, n plus 3, and so on. So subtract this value to this value, clearly we get the value of p. That's why we write p of x is equals to n plus 1 is p of x greater than n minus p of x greater than n plus 1. By above assumptions, p of x is equal to n plus 1 is equals to, what about p of x greater than n? It can be denoted as fn minus, what about p of x greater than n plus 1? If n equals to n plus 1, it can be written p of x greater than n plus 1, f suffix n plus 1. Now multiply t power n on both sides. T power n into p of x is equals to n plus 1 is equals to t power n into f suffix n minus t power n into f suffix n plus 1. We need to take care power values of t as x values here. Okay, that's why divide and multiply with t to occur power t value as n plus 1. T power n plus 1 into p of x is equals to n plus 1 is equals to, there is no need to change the power of t value because here f suffix value is n. That's why it can be written as usual t power n fn minus, here we need to transform the power of t value as n plus 1 by multiply and divide with the t. t power n plus 1 into f n plus 1. Taking summation n equals to 0 to infinity on both sides. 1 by t summation n equals to 0 to infinity t power n plus 1 into p of x is equals to n plus 1 is equals to summation n equals to 0 to infinity t power n fn minus 1 by t summation n equals to 0 to infinity t power n plus 1 into f suffix n plus 1. Take this is equation number 1. In this term can be taken as h of t. Let h of t equals to, consider this as equation number 2. Summation n equals to 0 to infinity t power n plus 1 f suffix n plus 1 is equal to h of t minus f of 0 means f suffix 0, because summation n equals to 0 to infinity t power n plus 1 into p of x is equals to n plus 1 is equals to, for n equals to 0 to infinity, here if you put n equals to 0 here, t power 1 p of 1 plus t square p of 1 plus 1 means p of 2 plus t equals, this can be written as gx of t minus p of 0, because what is gx of t here? Gx of t is t power x p of x. Here x is equals to 0 to infinity, but if we put n x is equal to 0 here, t power 0 into p of 0. But in this expansion we have no p of 0 value. That's why this can be written in the form gx of t. This is gx of t. There is no term of p of 0 in this expansion. That's why minus p of 0. Okay. Like this is considered as equation 3 and this is considered as equation 4, because from this notation we write the notation for this value here. That's why consider this as equation 3 and this as equation number 4. We know that what is f suffix 0 indication? Here f suffix n equals to p of x greater than n. That's why f suffix 0 is p of x greater than 0. We know p of x greater than 0 can be written as 1 minus p of. Here p of x less than or equal to 0 means should be p of x is equals to 0, equals to 1 minus p of x is equals to 0. So simply it can be written as p of 0. Number 5. From equation 4 and 5, summation n equals to 0 to infinity t power n plus 1 f n plus 1 is equals to of t h of t. f0 value is, from equation 5, f0 value is 1 minus p of 0. That's why minus of 1 minus p of 0 value is minus 1 plus p of 0. Now substitute equation 2, equation 3 and equation 6 in equation 1. Then equation 1 implies equal 1 by t. What is the summation of n equals to 0 to infinity t power n plus 1 p of x is equal to n plus 1 is equation 3. We write it as gx of t minus p of 0. 1 by t of gx of t minus p of 0. In place of sigma n equals to 0 to infinity t power n fn, it can be taken as equation number 2 as h of t minus, what about 1 by t sigma n equals to 0 to infinity t power n plus 1 f n plus 1 from equation 6, it can be written as 1 by t into h of t minus 1 plus p of 0. 1 by t gx of t minus p of 0 is equals to, take LCM here, t h of t minus of t plus 1 plus into minus minus p of 0. Now here t cancel. Gx of t minus p of 0 is equals to t h of t minus h of t plus 1 minus p of 0. Minus p of 0, here minus p of 0 both are cancelled. Gx of t equals to common h of t from these two terms, h of t of t minus 1 plus 1. H of t equals to gx of t minus 1 by t minus 1. What is the meaning of h of t? Here h of t means is the value of fn. What is fn here? Fn is the probability of x greater than n. The probability of x greater than n is equals to gx of t minus 1 by t minus 1 of P.G.F of P of x greater than n